Hi, I'm Norman Reese. I teach mechanical engineering technology courses mostly. And of course, with all the buzz about blended learning and flipped classrooms and online tutorials, I actually looked at some of Sal Khan and the Khan Academy, and it scared me, right? It excited me. There's a lot of opportunity there. This man who just started writing tutorials for his nephew or his niece, and then they started distributing, and he found there's a huge need, and so he's done all these 10-minute tutorials for almost every subject, all the way up through like sophomore level of college. And Bill Gates has got behind it and funded some stuff there. And I thought, can I do something like that with dynamics? Engineering, one of the hardest classes in engineering is dynamics, and it's a hard thing to conceptualize, it's a hard thing to communicate. And I thought, first of all, when would I come up with time to do that? But secondly, there's definitely, if a student could go back on a particular lecture, review an example problem, review some more explanation on their own, when they're doing the homework at midnight, instead of emailing me, they could be, there's a lot of advantages, okay? And so I'm going to tell you about what I did last semester in dynamics. The goals I had pretty well covered those, but the method, let's give you some examples and results, and maybe get to the technology if we have time. But instead of me doing these tutorials, I thought, why don't I make the students do it? Right? And then they can learn by doing it, and they are tech savvy, right? They should be able to do it probably easier than I can. Any problems with that? Absolutely not, because they're going to be able to present the theoretical knowledge very well, right? First, I want to, well, the main concern is if we have these tutorials, the students have done them, they're available from year to year, are they accurate? Are they right? Are they teaching the correct material? So, came up with a way to check for that. All right, so I assigned two-person teams. I said, here's a textbook section. We just covered this chapter 15. You take this section, you take this section, you take this section, and gave them some guidance. I said, use Microsoft Paint, a fairly inexpensive software, Sketchbook Pro. FrontCam is a nice little program that will just record. You can select whatever part of the screen you want to record. You hit record, and it records what occurs in that area of the screen and the voice. So you take a microphone, you run it into your computer, and it's a free download. It's $30 if you want to register it, right? And then it spits out this AVI file that's basically a Khan Academy-like document. But use a good quality microphone, use a good quality digitizer. Otherwise, it doesn't, it comes across pretty amateur. I provided them an example video, and then I said, let me also have them. It'll be nice if they all do these videos, they put them online, I'm going to post them on Blackboard so they all can look at them, but will they? So they will, because I'm going to require them to, right? I'm just going to assign it. Okay, you have to review 3 other videos, and I want you to evaluate each of those videos on, 1, the content. Do you have any suggestions for how they can improve the presentation of the video? And do you have a technical question that you can ask them related to their video? So I came up with a project description. We had first, before they spent a lot of time making a video, I wanted them to, let's just get a baseline check here. Submit a half-page description of what you're going to do, how you're going to record the video, and what example problem you're going to use, okay? And so I didn't want them to do an example problem that's already in the book as an example problem. Let's contribute some new knowledge here. So on 1 week, they submitted that, and then I had them do the video, submit that, but I also then wanted to get input on that video and have them do a final version, right? Because I want this to be a good quality product that can be used year to year. Okay, so you have to review 3 other tutorials that your classmates have done, and then submit a final video, and all this together will be worth 10% of your semester grade. Okay, similar to other projects we do in engineering. And so that I really wanted to reinforce their review of other classmates' videos. And so on a Blackboard discussion board, they were able to view the video and then post their question and their content comment. And I could see that who did that, and that all 3 of those had been done. And I also asked for this paper form because I wanted to reinforce that. And so for this particular team, and wanted them to write down what their question was, write down what their comment was, and then submit that as a deliverable. So one example, I think this will work here. So this is Team B Squared. They could come up with their own team names.
Hey everyone, this is Cash. Yeah, I'm Bert. And we're going to be covering chapter 15.2, Principles of Linear Impulse and Momentum for a System of Particles. Alright, so like the chapter, or the title says, it's the Principle of Linear Impulse and Momentum for a System of Particles moving relative to an inertial reference. This is obtained from the...
Okay, so that's just the start of an example here. You'll see on this example, they've used EduCreations, and about half of the students used an iPad. It's really nice, so you can write right on the screen. And then EduCreations, I guess, is an Apple site that they can just post these sources to, and they put in a web link and put that web link in your discussion board. So it worked pretty good for those people who used that. And then here were some comments. I'm sorry for the small writing, if you can tell. So underneath that posting in the discussion board were the comments. This one's from Jonathan. I like that you keep the actual picture of the problem up while you're introducing it. Question, was showing the equation for impulse necessary at all? I didn't see it touched on, and it was just replaced with numbers, okay? So we have a couple other comments here, questions. Reading the entire problem was a good, clear start. Simplifying the equation beforehand would have been beneficial. And yeah, so all of the teams provided their video. Here's another one I'll show you. Just see, it's pretty wide open what they could do with these videos. And so they, this one, yeah, got your attention? These are the Muffin Slayer team, okay?
I think we're talking about impact, specifically central impact. Central impact occurs when the direction of motion of the mass centers.
So they enjoy that kind of thing. This one was posted to YouTube from a software. I'm not sure what software he used on that, but again, they got comments on their video, and he actually, his teammate bombed out, dropped the class right about that time, so he did it all himself. But for each of these teams, they got their names, they have their topic, and they have the web link to their video. And I think we've gone through that enough. So afterwards, I had the student reflection sheet. Let's evaluate. Did this work? Did they like it? Was it something we should keep doing? I scored it from like the #1 category, how much you learned from doing the video tutorials. And from 1 to 10, very little to very much. A lot of high marks here that they learned a lot from doing the video tutorial. The average was 7.0. How much did you learn from watching other people's tutorials? Okay, that's less. Like, people did it, and they learned a little bit about it, but of course they didn't learn as much as doing their own. How much did you enjoy it? Usually, last year I had them design a catapult and compete and analyze a catapult dynamically, and so kind of mixed results here. A lot of them liked it. Some were more hands-on. They would have really liked to build something that throws rocks or something. What did you learn from the exercise of reviewing other videos? It was interesting that made them to watch somebody's video on section 15.3 and be expected to ask a technical question on it. They had to like go back and read section 15.3. Okay, and so a lot of comments I got here were it was a good refresher. It made me review that section. It made me realize how important it is to be clear, to give the givens, to finds, and give the details that they don't really expect. What did you learn about from commenting on other students' videos? Just the more feedback on clarity, getting input from their classmates is very powerful to students. They'll listen to what they say more than they'll listen to what I say, right? And so I wondered if students were a little bit hesitant to write on the discussion board an open, honest evaluation. I said, maybe we should submit that on paperwork, and I'll look at it and give proper feedback. But overwhelmingly, I think 92% of them said it did not change how they would provide feedback. These guys are very used to online feedback, all right? In fact, I think they may be more open in online public feedback than any other kind of feedback. And then I did ask, because I'm always worried about, you give a team project, does one person do it all? And I tell them up front, going into this, you will be evaluated, you will be asked to rate your partner on the amount of contribution that he made to the project. So you know that going in, just a little bit of accountability there, and almost all of these were 50-50. It was like 40-60, so they come off pretty good. I just got a couple minutes left. Got asked for suggestions for improvement in 3 different areas. I just kind of summarized those here. But some people wanted more creativity, allow some flexibility. Like, don't just require us to do a computer software, but maybe a student writing on a whiteboard and we videotape that. That should be okay. But another comment, of course, is require all the students to use the same software. Okay, so you always get mixed comments, right? And one of the biggest difficulties was this, where I said, okay, students, go find this video software. Here's some possibilities. Provide me a video file. And a couple teams took right off with that, but a couple of teams were like, they struggled. They came up with this one, their computer crashed, and they tried to do this one, and it took a long time to learn how to do it. And these, I got to show you this one because it's they really didn't want to use a video software. You can tell me how they did this.
Today we're going to do a dynamics tutorial over acceleration in terms of distance to velocity in terms of distance graphs. We're going to use A as acceleration, S for distance, and V for velocity.
I said, I don't want to see you writing on a whiteboard.
It's A is equal to V dV over ds. And we're going to use that in the form of A ds is equal to V.
Do you know how they did that?
This equation comes
Like
from the
taking photos after each writing and then compiling all those.
And A is equal to dV over dt.
And surprisingly, this team said they spent more time video editing than learning anything about dynamics. But that would be... So a few other... basically, some people like video tutorials and some people don't. And what I found, interestingly enough, was that the higher performing students feel like the tutorials are too slow. Just give me a written example, I can fly through that and understand it. Don't make me... And these were all limited to 10 minutes, like between 7 and 10 minutes of length. And so, but other students were like, this really helps me because I can look at it at midnight when I'm awake instead of 8 o'clock in the morning when I'm in your class, So it's good to have that video resource when other resources are not available. A lot of people just like being able to see a problem worked out is better than looking at a written example in the book, okay? But they need to be short, they need to be accessible, navigable. How do I find the video I need for the thing I'm looking, for the item I'm trying to learn? Good suggestion, also include a physical demonstration. So like, if we could incorporate actual models and students could build a contraption that would demonstrate this principle, like they do actually in other dynamics classes, and video that as part of, we could have a very, very powerful library of example problems, student lecture, and project hardware demonstration that would be very cool. A couple of suggestions I'll just close on. Discussion board was, that peer review was more powerful than I thought it would be. Just making them go back and look at their classmates' videos, they learned a lot from that, and they were able to improve their own videos a lot from their classmates' reviews. Had a little trouble getting feedback forms from everybody. I did it after the project, and students were like dropping or not, getting hired and disappearing from class. So we need to give more coaching on which software to use and help them with that, I think, so they're not spending a lot of time on video editing instead of learning dynamics. and give some options for building contraptions. It'd be really cool if we had in our library or the new student center a room where student teams could go with a video camera and a microphone and equipment just to make videos, class things like that. And one thing I wasn't sure of is we're putting diagrams from the book on YouTube. I'm not sure the publisher was, we didn't check with the publisher, and I'm not sure if Hibbler really wants his work posted online. But this is a really good digitizer pad, the Bamboo, and I think what Salcon actually uses as well. $80 can get you one of those. A couple items. LiveScribe and Iris Note, these two are just pens that they're not really good for putting on these kinds of presentations, but this is a pen, you just hit record, and it records the audio while you're writing and creates a PDF with sound. So later I can go back and I can click on my mouse and say, what was that point? Click on it and it plays back that sound, the audio that goes with it. So I use it at conferences and things like this here today.
I have one of those pens that I can loan out. It's over in the curriculum office.
Arts and Sciences has two, I think, that Karen can loan out. Iris Note, but you need a special paper, a special notebook, and it has little record, pause on it. It has micro dots on it so it knows where the pen is, and a little camera in here that takes pictures of that. Not really useful for providing like tutorials for online work, but maybe for putting notes online or something like that. Iris Notes is kind of unique in that you can use it with plain paper, and you just hook this little receiver up to the top of your page, use a special pen, and then it will record what you write, and it's really good with optical character recognition. So it'll pull it in, and you can convert that handwriting into typed text. But it doesn't seem to work. Something about the lighting or something on campus here, it doesn't seem to work at all. So it works for me at home, but not on campus. I don't know if it's fluorescent lighting or what it is. So all these options are out there, just so you know. And I don't know, no time for questions probably, but.